Okay, this is a difficult problem for a number of reasons, but let's get started. We've got a story here, and in this story, a person's Mackenzie can spend at most 2 hours on math and biology homework tonight. So we want to translate that statement into an inequality. At most 2 hours on math and biology. Well, that means the amount of math homework plus the amount of biology homework is going to be less than or equal to 2 hours. She cannot spend more than 2 hours, so that means the math plus the biology has to be less than or equal to 2 hours. I made it 120 because it said to work in minutes. So that's the first inequality. Math plus biology less than or equal to 120 minutes. The next one says biology reading always takes at least 45 minutes. So that's the biology homework is greater than or equal to 45. At least 45. 45 or more. And lastly, it says because there is also a math hand-in due, Mackenzie knows that math is going to require more time than biology. So that's this inequality. Math is greater than biology. The amount of time on math is greater than biology. So we need to graph these. And it said to put M on the x-axis, or the horizontal, and B on the y. So in order to help me think about this, I pretended that M was x and B was y, because I know how to graph x and y better than it just helps me think about it. So whenever I saw an M, I put an x, and every time I saw a B, I put a y. Over here, we get this. So I basically translated these inequalities into inequalities in terms of x and y, so I know how to graph them more easily. I'm more familiar with those variables. So this one, I changed to the equal sign version so that I can find the boundary line of this inequality region. And then I subtracted x from both sides to get it into y equals mx plus b form. So one of the boundary lines is y is equal to negative x plus 120. This one is b is greater than or equal to 45, which changes to y is greater than or equal to 45. The boundary line is then y is equal to 45, and that's going to be a horizontal line. And then m is greater than b, m is x, b is y. So you get x is greater than y, which is a boundary line x equals y. And then, you want to reverse these. Y is equal to x. That's sort of like slope-intercept form. Y is equal to 1x plus 0. So now we've got these three boundary lines. Y is equal to negative x plus 120, y equals 45, and y equals x. We need to graph those. Well, first of all, we had to decide on intervals for the graph. Okay, I knew the y-intercept here was 120, so I knew I couldn't count by ones. I counted by tens, okay, to get up to 120. And then to make it easy to graph, I also counted by tens on these. So at least we're counting by the same thing on both axes. We can't always do that, but it's easier if you do. And then I know that the slope is negative 1 here. That means every time you go down 1, you go right 1. Or if you go down 10, you go right 10. So this is going to be that 45-degree angle sloping down with a slope of negative 1. Y is equal to 45 is that horizontal line here through y is 45. And the y equals x line is y equals the slope of 1, and it goes through the origin. So that's here, and it goes up 10 over 10, up 10 over 10. So that's that. So we get these three lines, and now we've got to decide, do we shade above or below each one? So, you do your testing, which I won't go through now, but you just test 0, 0 in all of the inequalities, the original ones, and you end up getting this little triangular region here, okay? And then it says, is 60, 50 in the feasible region? It is, okay? It is. That's 60, 50 right there.